Start streaming.
Way back, long back around in 2017, Ministry of Power issued a policy on 17/11/2017 for biomass co-firing and subsequent advisory to all power plants, state governments by CA to promote use of biomass pellets. Ministry of Power set up national mission on use of biomass in thermal power plants in July 2021 to address the two main issues, that is air pollution due to farm-stable burning and to reduce carbon footprints of thermal power generation. Well, there is an old saying that a journey of 1,000 miles begins with a single step. Missions evaluation.
excuse me सर.
Yeah.
सर आपके माइक्रोफोन से बहुत ज़्यादा आवाज आ रही है सराउंडिंग में, तो प्लीज उनका कोई होगा तो लोग.
Sir, is it clear?
Yeah, you are clear sir very much, but surrounding में आवाज आता है.
कुछ वो चल रही है, एक प्रेजेंटेशन चल रहा है. I'm presenting somebody to कुछ वॉइस से कुछ बातचीत चल रही है.
लिंक हमको शेयर कीजिए YouTube वाला. हिंदी अगर लिखनी चाहिए.
Sir, is it okay now?
No sir, background noise is there. Don't know if somebody.
चारों तरफ से नॉइज आ रहा है, कुछ सुनाई नहीं दे रहा है. आधा चीज हो रहा है.
Just put their mic on mute. इको है सर, इको.
Sir, this is a humming sound. You can move forward, sir.
Sir, let's. There is some humming sound. Yes, sir. Sir, just give us 2 minutes. We are changing this.
दो जन एक साथ कनेक्ट किए, एक ही आईडी में गया. आईडी एक हो गया. तुम्हें दिख और पीछे बैठना चाहिए.
ईयरफोन लगा लेने से आई थिंक इट विल गेट रिजॉल्व.
उनके बाद हम लोग की ब्रेक दे देंगे ना, उनके बाद कुछ नहीं बोला जाए तो पीछे की जरूरत नहीं है, पहले कुछ ब्रेक दे देंगे. अभी वो लोग ऑडिट आया, बोलता अभी आगे टैली एक लोड करो, अभी आगे के टैली लोड करो. जाना होगा आगे, बोलता कि जाना अभी आओ ऑडिट का नहीं लोग काम करेगा. अपना मशीन में बैठा हो, अपना मशीन में बैठा हो, काम बंद करो अभी. अच्छा फर्स्ट तो नासिर का रूम देना ही गलत था।
हाँ
फैकल्टी का रूम बंद है।
सुदीपनाथ सर कहीं
नासिर का
अदरवाइज अगर कोई टीचर को पूछेगा तो वाइस क्लियर होने
अपना सुनिए ना।
अभी वेट कीजिए वो बोलते हैं कि
ये किसका है? बकर सर का।
ये उन्हीं का है उन्हीं का ही
Sir, shall I?
सुदीपनाथ सर कोई नहीं कर रहा है अच्छा उनकी इसमें
Is it okay, sir? Now,
Yes sir, it is okay.
fine. So, sir, as I was explaining you that there is an old saying: a journey of 1,000 miles begins with a single step. Mission's evolutionary journey also started with a thought to find a solution for stable burning and reduce the thermal power plant's carbon footprint. Every year, around 22 million tons of rice straw is burnt in Punjab and Haryana. Since last few days, Delhi NCR regions has been facing heavy pollution level and getting covered under the blanket of smoke in the month of October, November after harvesting of paddy.
स्क्रीन को
It was the time when it was decided to explore the possibility of use of the biomass for power generation. MOP issued a policy in 2017 for biomass co-firing and subsequent advisory to all power plants, state governments by CA to promote use of biomass pellets. Ministry of Power set up national mission on use of biomass in thermal power plants in July 2021 to address the issue of air pollution due to form stable burning and to reduce carbon footprints of thermal power plants.
आप यहाँ के बोल दीजिए।
Well, a dream does not become reality through magic. It takes sweat, determination, and hard work. Mission journey was not as smooth as it looks. Yeah. Mission was carved out by the great will of our visionary leaders, persistent effort, and well thought out plan.
सर
Here, yeah.
सर पीपीटी प्रेजेंट कीजिए रन कीजिए फुल स्क्रीन कीजिए
It's on full screen.
नो सर इफ इट इज नॉट रन सर
Are you not able to see?
No, but only starting.
स्टार्टिंग स्लाइड इज शोइंग सर
Sir, screen is visible, but you are in a first slide only.
No, I am on the
Not
background.
changing. Slide is not changing.
आ रहा है
Is it changing?
Yes.
यस सर
Okay.
सर कुड यू प्ले इन फुल स्क्रीन
So it's in the full screen only.
बट ये शोइंग टू
Sir, put it on slide mode.
Window share.
अभी चल नहीं रहा है उनका क्या है कि फर्स्ट स्लाइड में रुक जा रहा है
पीपीटी अपडेट सॉफ्टवेयर जो होगी ना 2016 उसमें फुल स्क्रीन करने में उनको दिक्कत है।
हमारा नहीं तकलीफ
वो ऐसे प्रेजेंट दे रहे हैं दिख भी रहा है लेकिन
उनको
स्क्रीन उनका चेंज
नहीं हो रहा है स्लाइड
स्लाइड।
So I request all the participants to please bear with this. I think there is some technical problem. Pakhar sir is going to get it right with his PPT.
अभी प्ले मोड में है Okay, madam. Okay, madam.
So now,
Okay.
Yeah, now it is
right.
okay, sir. Now it is okay. वो कहाँ है?
मेरे पास नेटवर्क लॉस हो गया।
आपका आप इसी में आ जाइए, इसी में आ जाइए। इसके बाद ना आप 10 मिनट्स टी ब्रेक देते हैं। वी टेक ए स्मॉल ब्रेक, तो मेरे को मैं फ़ोन कर देती हूँ इन द मीन टाइम। तो ये जरूरत नहीं तो कंटिन्यू कर दूँगी।
ठीक।
Sir, now it is clear. You can start, sir.
Sorry for the disturbance, sir. I think now it's visible to everyone. Can we go ahead, sir?
yes,
Yeah. So, sir, as I explained you regarding the evolutionary journey of our mission, now I will talk something about background, because we have to understand that a dream does not become reality through magic. It takes sweat, determination, hard work. Mission journey was not as smooth as it looks. Mission was carved out by the great vision of our visionary leader, persistent effort and well thought out plan. Here in this slide, you can see that every important step that lead to this phenomenal start. You can see that in 2017, there was issuance of policy regarding biomass co-firing by Ministry of Power and subsequent advisory to all power plants state government by CEA. In September 2018, technical specification for biomass pellets was developed and shared with all. In December 2019, MOP constituted a committee under chairmanship of member Thermal CEA for developing methodology and to indicate rates of agro-residue based in the bill form. In September 2020, committee constituted under additional secretary MOP to investigate the constraint in supply chain, separate milling system, regulatory issues of biomass pellets and agro-residue for increasing percentage of co-firing of pellets. Next slide, please. In November 2020, committee constituted under Chief Engineer CA to prepare report for possible areas of research in promoting co-firing of biomass pellets, and report was finalized. Immediately after that, in February 2021, draft concept note including modalities for the national mission on use of biomass in thermal power plant was proposed by CA, and in 2021, meeting held under the chairmanship of Secretary Power to discuss regarding this draft concept note of CA regarding our national mission on use of biomass in TPPs, and after deliberation, a structure of mission was finalized. Soon thereafter, in July 2021, MOP set up National Mission on Use of Biomass in Thermal Power Plants on 12 July 2021, constituting a steering committee, executive committee, mission directorate, and 5 subgroups. Next slide, please. Our mission is constituting a steering committee, executive committee, and mission directorate. Basically, it's a 3-tier structure, and mission director is constituting of 5 specialized subgroup. All the aspects of the biomass energy sector was considered thoughtfully, and the 5 subgroups were created, each subgroup covering the specific area. For example, subgroup 1 taking care of all the research aspects, subgroup 2 regarding the development of technical specifications, boiler design for biomass co-firing, safety aspects, scalable prototypes, simulator designs, etc. Subgroup 3 was meant for the taking care of supply chain issues, logistics, and business development. Subgroup 4, headed by B, was taking care regarding the identification of labs and certification body for testing of agro-based biomass pellets. Subgroup 5, headed by MOP itself, is taking care regarding all the issues pertaining to regulatory framework and economics of biomass co-firing in coal-based thermal power plant. Next slide, please. Here in this slide, I have briefed regarding the mission objective. When mission was carved out, the objective set by the mission was covering almost every aspect of the biomass sector. However, here in this slide, I have highlighted some main and salient objective. The first and foremost important objective regarding the mission was to increase the level of co-firing from present 5% to higher level to have a larger share of carbon neutral power generation from the thermal power plants. To take up R&D activities in biomass and boiler design to handle the higher amount of silica alkalis in biomass pellets, to address the constraints in supply chain of biomass pellets and agro residue and training of personnel, to resolve the regulatory issues in biomass co-firing, to formulate mechanisms to provide initial capitals, seed financing to encourage entrepreneurs and SMEs to establish pellet manufacturing facilities, to identify critically needed infrastructure and encourage necessary investment by working with government and stakeholders as well as industry and academia, to sensitize all stakeholders like ministries, departments, state governments, farmers, local bodies, agencies, etc. It was also the role of mission to prepare guidelines, release of RFQ, RFP, other requisite documents, selection of host institutes, signing of MUs, release of funds, preparation and evaluation of budget, organizing meetings of expert committees and experts group, etc. Next slide, please. Well, after forming of the mission, the policies regarding the use of biomass in thermal plant has already been finalized and issued. Revised policy of MOP mandates for biomass utilization for power generation through co-firing in coal-based thermal power plant. It was issued on 8 October 2021, and it mandates that every power plant have to use at least 5% of biomass in co-firing. Few of the main points regarding these enabling policies are that any power plants, the policy shall be in force for 25 years or till the useful life of thermal power plant, whichever is earlier. One more important point regarding this is that all the cost can be claimed under the ECR due to co-firing can be claimed under change in law provision. Another part of this our enabling policy is regarding RPO, and the important point is that the power generated from co-firing of biomass in thermal power plants is renewable energy and eligible for meeting non-solar renewable purchase organization. Next slide. There are different actions carried out by mission regarding guidelines. Model contract for procurement of biomass is under finalization and expected to be released very soon. Guidelines for exemptions to TPPs has been finalized and issued to all TPPs for their reference. Regarding technical assistance, SOP has been prepared and issued to all TPPs for their reference. Issues concerns raised by GENCOs on biomass co-firing in their TPPs has been addressed for start of biomass co-firing at the earlier. Regarding monitoring, reporting is being done on regular basis for biomass uses and tender status. Database has been developed for the vendors. Identification of labs and certification bodies. 8 NABL labs have already been identified for biomass testing as per STM standard, and list has been circulated to all GENCOs and states in December 21. Research project on estimating paddy content in biomass pellet and loss of GCV due to storage has been already initiated through missions approved one. Regarding training and awareness, as you all are seeing, capacity building programs for pellet manufacturers and awareness programs for farmers and GENCOs are being organized. Next slide. In the last slide, as I was explaining regarding the model contract, a model contract has been developed for addressing the concern of pellet manufacturers and GENCOs to provide a common standard guideline for promoting the biomass industry. The salient features regarding the model contract are that it's a long-term contract. The period of contract shall be for minimum 7 years. There is also provision for the price adjustment for GCV. There is provision regarding the rejection, and for the non-serious bidder there is a provision for the security deposit And finally, there is another important clause regarding price variation. For destination price quoted by the supplier shall be subject to adjustment during performance of the contract to reflect changes in the cost of labor, diesel, electricity, etc. Next slide. 2 numbers farmers awareness program has been conducted at NPTI Faridabad and Nangal for sensitizing the farmers regarding the economic use of agri residue. A total of 65 farmers participated in Faridabad and around 72 farmers participated in Nangal from various districts from Punjab and Haryana. Next slide. 2 numbers capacity building programs has also been conducted for our pellet manufacturers at Badarpur and Nagpur. Total of 82 manufacturers participated in Badarpur and around 60 manufacturers participated in Nagpur on 30th 11/21. Next slide. This slide is regarding progress in the biomass energy sector, and it's a matter of great pleasure and pride that within a very short duration, we have achieved around 62,000 metric ton co-firing in the thermal power plants. Next slide. Not only the progress is in regarding the co-firing, there is a substantial progress in the tendering also, and you can see that around 15 million metric ton biomass is either has already been awarded or in the final stage of award. Next slide. A website has also been developed by the National Mission for providing a common platform to all the stakeholders of the biomass sector, that is our farmers, pellet manufacturers and GENCOs. Features of mission's website have provision for all the stakeholders, and for the GENCOs there are too many provisions. Especially it's having a vendor database has been and it's being updated on regular basis for GENCOs, which can be accessed. Next slide. Additionally, it have features like tender detail management, actual consumption management, consumption forecast management, pellet costing management. There are different multi-information system also, like actual consumption report, tender details report, costing reports, forecast report, etc. Next slide. These are the few prominent mission achievements. You can see that revised policy for mandatory biomass pellet co-firing in all thermal power plants has been issued by MOP on 8 October 21. 8 NABL labs has already been identified for biomass testing as per STM standards, and list has already been circulated to all GENCOs in the states. Reporting and monitoring is already being done on regular basis for biomass uses and tender status of thermal power plants. Issuance of model contract for procurement of biomass pellets by generating utilities is on the way and expected to be released very soon. Guidelines for exemption to TPP has been finalized and issued on 4th February 2022. Vendor database has been developed for facilitating the biomass supply chain. Framework for online updation, reporting and monitoring has been developed through mission website. Research project on estimating paddy content in biomass pellet and loss of GCV due to storage has been initiated through mission subgroup 1. 02 numbers farmers awareness campaign, 02 numbers capacity building program for pellet manufacture, and 01 number capacity building program for GENCOs has already been conducted, and one is being conducted today. Awareness campaigning through different newspaper advertisements, banners, hoardings is already being done in different states. Next slide. Well, this brings me to the end of my talk and presentation, and I would like to finish by quoting the lines of prominent businessmen that growth is never by mere chance, it is the result of forces working together. So I welcome each one of you to be a part of India's story of green energy transition through National Mission on Use of Biomass in Thermal Power Plants, where mission is going to work together hand in hand with you all.
डिस्कनेक्ट हो गया डिस्कनेक्ट हो गया डिस्कनेक्ट हो गया Thank you, sir. Thank you for your valuable presentation. Next presentation by Jitesh Srivas, Deputy Director Thermal Engineering and Technology Development CA. Sir, Jitesh sir.
Yes,
Please.
good morning to all of you. Is it visible?
Yes, sir.
Okay. Is the presentation visible?
Sir, presentation is visible, sir.
Okay, morning to you all. I'll be speaking about the policy and regulations on the biomass utilization for power generation through co-firing in coal-based power plants. Let me brief you about the background of this. Basically, due to the stubble burning problem in the North India, due to the burning of this stubble, there is a problem of air pollution. So, also about that, India has committed to its greenhouse emissions in the Paris Agreement. So, to address all these issues, there has to be scientific solution for that. So, Government of India came up with this co-firing of biomass that will solve the problem of all these things, including will improve the air quality index, it will create an additional income, and it will reduce definitely the burning of agro residue, which is leading to this air pollution problem, as well as it will generate the employment opportunities, as well as it will establish the decentralized pellet manufacturing, which will increase the employment. So, regarding the policy,
Good morning. Next presentation yours.
in November 2017,
Sir, next
Ministry
presentation
of Power
yours.
has issued a policy regarding co-firing of biomass, in which it was not mandatory
Mute करके please.
to co-fire
ऐसे नहीं होता.
the biomass in the coal-based power plants.
अच्छा,
But
yes.
in the subsequent amendments and revised Ministry of Policy of 2021, it has been made mandatory to fire 5% of the biomass. Regarding the regulations, this policy covers basically two major aspects of regulatory issues. The number one is renewable purchase obligation, that is non-solar one, and the second is merit order dispatch. So let me cover the.
Excuse me, sir.
Yes.
Sir, your presentation showing hide. You are in first slide only.
I have not shifted it. I'm
Okay. Please remove the hide.
hide. Oh, okay. Okay. Is it okay now?
Yes, sir.
Okay. So let me start with the presentation. This is the background which has been discussed in the inauguration session as well as my previous participant, that India generates a lot of waste every year, and out of which large part remains unutilized. So we have surplus biomass available in India. Around 40 to 50% of the total paddy straw are burned in the field. So I've already discussed that this can be utilized to generate power
लेट हो गए.
rather than burning in the
इसके
fields.
बाद और एक दो presentation है उसके बाद lunch break.
Biomass co-firing along with the coal is a method of generating carbon neutral electricity.
हाँ,
So
lunch
India is
time.
existing with coal-based power infrastructure. So it will add on and reduce the stress on the fossil fuel which they are having. Now in this slide, basically the objective of the slide is just to show that we have surplus of biomass in the country. We have 228.5 million metric ton per annum of the biomass available. We have covered 17 states, and there is a data of coal capacity and the surplus biomass. So there are some statistics in this slide. Okay, the benefits I have already discussed, that it will eliminate or minimize the burning of agro residue. It will improve the air quality index. It will create additional income. it will encourage the establishment of decentralized pellet manufacturing and thus generate employment opportunities. The reason being this biomass all through has came is because the NTPC has successfully demonstrated co-firing of 7% blend of biomass pellets. So because of NTPC, this has been an encouragement, and therefore we have a policy on this. So in November 2017, the MOP came up with this policy. All fluoride-based bed and pulverized coal units, except those having ball and tube mill in public, both for public and private generating utilities, the policy holds, shall endeavor to use 5 to 10% blend of biomass pellets, considering the safety aspects. It is also said that CA shall issue a specification for the pellets. Appropriate commission will determine the compensation to be allowed for the increase in tariff for cost of generation on account of using biomass pellet. That will be taken care of through ECR, that is energy charge rate, or the change in law, which will be covering in the subsequent slides. This is the regulatory issue, this one, a merit order dispatch. So the increase in cost of generation will not be taken into account for the purpose of merit order dispatch of electricity. With coming out to this policy of 2017, there were few committees and reports relating to the biomass. The number one was technical specification, which holds that what could be the minimum criteria, or what should be the technical specification of the pellets, both for non-torrefied and torrefied one. Then we have the chairmanship, under the chairmanship of member thermal, CA to look into the metallurgy for arriving at the rates. So regarding the agro-based residue pellets, this was based on the calorific value. So if I'm not wrong, it was around for 1000 calories non-torrefied one, the cost was around 1.9 rupees per kg, and for torrefied it is 2.1 rupees per kg per 1000 kilocalories. Right? Then we are also having other committees under the additional secretary, Ministry of Power, to look into this one, merit order dispatch, the regulatory issue. So it has been decided that merit order dispatch will not, the increasing cost of this one will not be considered for merit order dispatch. Then we have also a committee constituted under the Chief Engineer, Thermal Engineering Technology Development, CEA, to undertake the research and utilization of agro-residue thermal power plants, increasing the percentage of co-firing of biomass pellets. The reports have been submitted in August 2021. The areas of concern were the research areas identified in this report.
Okay, sir. Thank you.
Subsequent to which there has been subgroup formations which are taking this subgroup biomass under the biomass mission, which have been taking this report findings. So after this policy, another regulatory issue, the non-solar renewable purchase obligations, the power generated from co-firing of biomass in coal-based thermal power plants is considered to be a renewable energy, and this is eligible for non-solar RPO. So this was a major amendment. Now, okay, coming on to the MOP policy revised with subsequent amendments of 2021 October, it made mandatorily firing of 5% biomass. So for a different type of milling system, according to torrefied and non-torrefied pellets, we have this one. For example, the ball mill mandatorily use 5%, and the obligation shall increase to 7% with effect from 2 years after the date of issue of this policy. The second one is ball and race mill, which will be using only torrefied pellets. 5% is mandatory. The same holds 2 years from the date of issue of policy, obligation will increase to 7%. Regarding the ball and tube mill, this will be using 5%, but this is having certain technical constraint, the ball and tube mill. So for this one, the volatile content has been kept under 22%. So apart from this, we have a case, for example, a reserve shutdown, or we are not being able to operate due to the dispatch of merit order dispatch. So for that, if you are having these constraints, then you have to increase the percentage of co-firing up to 10% in other operating units or plants. So this is what is the table I was explaining, that for the ball mill, we can use both torrefied and non-torrefied pellets. Mandatory 5% you have to fire, and subsequent in the 2 years you will be having 7% increase. You have to increase. For the ball and race mill, you have only torrefied pellets, that is you have to fire, co-fire. Then same thing, 5% and 7%. For the ball and tube mill, which is having technical constraint, you have to keep volatile content 22%. Mandatory fire is 5%. The 7% obligation has not been fixed for this one as of now, because MOP policy, it is there that it will be reviewed from time to time. Okay. Exemption and relaxation for co-firing. For example, if there are applications or the power plants are seeking exemption for co-firing, that will be held, that will be considered on case-to-case basis. There is a 6-member committee headed by Chief Engineer TETD to look into this matter, and the representatives are from NTPC, BAIL, CPRI, Ministry of Agriculture, and Mission Directorate. Okay. So these are the key highlights of this one. The policy will be in force for 25 years. The minimum percentage of biomass for co-firing will be reviewed from time to time. Minimum contract period for procurement of biomass pellets by generating utilities for 7 years, so as to avoid the delay in awarding contracts with generating companies every year, and also to build up long-term supply chain. Okay. In the morning I heard that the capex and all those things, there was some query. So this slide is for Sir who has asked this question. So for projects under set up under Section 62 of Electricity Act 2003, the increase in cost due to the co-firing of the biomass pellet shall be passed through in energy charge rate. And for projects under Section 63, the increase in ECR due to biomass co-firing can be claimed under change in law provisions.
Thank you.
Apart from that, additional cost on ECR shall not be considered in deciding merit order dispatch of the power plant, so it remains untouched. And obligated entities such as DISCOM can meet their RPOs by buying such generation of co-firing. That MNRE notification 2019. Okay, the completed and the ongoing activities related to the revised policy. Number one is methodology for testing of paddy content has been identified. The framework for reporting of quantity of biomass pellets has been developed. Issuance of model contract for procurement of biomass pellets for a period of minimum 7 years. So this is under finalization, as well as we have a penalty and reward scheme for TPPs based on prescribed percentage. For that, the draft is also undergoing. It's under finalization. Okay, so under this National Mission on Use of Biomass, we have 3 tier structure. Ministry of Power is the nodal one. Then we have steering committee, executive committee, and mission directorate, which will be collaborated by 5 subgroups. These are the subgroups. R&D or characteristics of biomass, which will be headed by DG CPRI. R&D on boiler design, which will be headed by Director Operation NDPC. Issue of supply chain and business development will be led by AS Thermal. Designated labs and certification bodies will be headed by DG VEE, and regulatory framework economics of co-firing will be taken up by Joint Secretary RNR MOP. Thank you for listening, for the patient listening.
Sir, one question, sir. What will be the cost, sir?
Cost for what?
Per kcal or for 1000 kcal? This biomass.
So this is for non-torrefied pellets. It is 1.95 rupees per 1000 kilocalorie. Right? For torrefied pellets, it is 2 rupees 10 paisa per 1000 kilocalorie, as identified by the committee constituted by the Ministry of Power.
Excuse me, sir.
Sir, what is the CV of this pellet, sir? CV.
Sir, actually, this non-torrefied pellets, the CV that is in the range of that is around some 3500 that we have considered. And
ARB or ADB, sir?
But sir,
ARB or ADB?
it is ARB. As it is.
Sorry for disturbance, please. After this session, one question session is there. After that one, we can discuss on the question session.
Yeah,
Okay,
sir.
Okay.
Sure.
Sir, thank you, Jitesh sir. Thank you for valuable presentation. So may I request Shri Rohit Grover, Manager NTPC Dadri, the presentation on biomass co-firing and experience and combustion practices. Sir, please. Rohit sir.
Sir, echo is happening, not listening properly.
Rohit Grover sir.
Yeah. Good afternoon. Am I audible?
Yes sir.
Okay, good morning. Sorry.
No, it's okay, sir.
My PPT is visible?
Yes sir.
Okay. I hope this PPT is being seen over there in full screen.
Yes sir. Yes sir.
Okay, thank you so much. Thank you so much.
Thank you.
Okay. Good morning, senior dignitaries of NPTI, and thanks for giving me the opportunity of interacting with all the lovely audience over here, and respected senior members of NPTI, respected senior members of NTPC, respected senior members of National Mission in Biomass, and respected senior members of West Bengal government and Ministry of Power. Today my topic is sharing with you the experience of NTPC Dadri of co-firing the biomass pellets and how we have done in our plant. Basically, I have an experience of around 12 years in operation, 210 megawatt unit and 500 megawatt unit. So whatever we have learned in the past 5 to 6 years over the firing of the biomass along with coal, I would like to share over this with this presentation. Now, this we all know that from where did it come, that why we need to fire the biomass. This was just because of the huge smog which left Delhi NCR paralyzed because of air pollution. So we won't discuss much on this. We'll be focusing more on technical part. So my presentation will be more concerned regarding, we'll discuss about some background, we'll discuss about first phase of trial run of operation, how we started it, what is now NTPC Dadri experience over a period of time, what are the requirements which you need to have any power plant before going commercial, what are the SOP, and what is the way forward. So background, as previous two presentations have mentioned, that we have a huge stock of biomass lying around in the fields which is being burned unnecessarily and creating air pollution. So what we can bring that into the economic value chain, and also it can be a win-win situation for nature, air, power producers and farmers also. And it will also lead to a generation of jobs and employment opportunities also. So in 2017, because of 2016 smog, 2017 NTPC Dadri was selected as the pilot project for implementation of co-firing pellets with coal. So now, since as we all know, as an operation people, we are totally scared if we are asked to burn any new fuel in our boiler, which is not particularly for which our boiler was not designed earlier. So there were many perceptions, there were many apprehension that whether this fuel will be sustainable or not, whether if there will be any fire or not, or will this lead to milk choking or not. This all problem was discussed before firing in NTPC Dadri mills. So firstly, NTPC Dadri comprised of 210 megawatt of units of four units are of 210 megawatt and 2 units are of 500 megawatt. So we have fired biomass in both the units, but the first time biomass was fired in 210 megawatt unit. Before firing that unit, the whole specimen which we got as a sample of pellet, this was tested by our Netra lab. Netra is NTPC research wing, which basically tests the samples and tells us what is the composition of it, which I'll show you in the coming slide also. So before firing that, we tried to basically, because it was being fired for the first time, we tried to summarize the what should be the SOP, what should the basic SOP, which should precautions which we should take before firing pellets for the first time. We started with first firing of 5% blending, and then went up to 7.5, and we demonstrated 10% of the biomass firing also. So before firing that, we need to indent the pellets from the pellet manufacturer. So these are the specifications which we raised and which we got at our plant. That what should be its shape, what should be its length, what should be the kilo GCV, whether the moisture content, what it should be. Moisture content is very important in pellets because they are very hygroscopic in nature. They catch moisture of the atmosphere very easily. So moisture content of biomass is very important because on that basis we accept a lot or we reject a lot basically also. So that we'll see in the coming slides also. And what should be the particle size, this is also mentioned over here. Now this slide is of important because this is something technical related. This is the distribution of proximate analysis of what is the distribution of when we do proximate analysis of 100% core and then 100% biomass. As you can all see that with mostly the parameters are same. When we talk about GCV, someone just asked about the gross calorific value. So gross calorific value which is being used in NTPC Dadri, it is around in the range of 3200 to 3800 of kilocalorie per kg. Now with 5% biomass blending, it more or less remains same as you can see from the last column. What is concerning for us is the from the last fourth row and volatile material column. You can see that volatile matter which is contained in the biomass is around huge. It is 67%. So 67% of the content in the biomass is volatile matter, which is a huge concern of as an operation engineer, as a power plant burning. If I think about whether my mills will be able to pulverize that and whether there won't be any ignition in the mill itself, this was a concern as an operation engineer. Because as you can see, for 100% coal, the volatile matter is just 22% in our Indian coal if we talk about. But in case of biomass, it's 67%. So that is all which led to whatever you will see, what are the precautions which we are taking, what are the SOP which we have formed. These all are more or less related to this because high volatile matter content in biomass. Now this is the ultimate analysis. This is of again these 4 rows shows the 100% coal and then 5% blended and 10% blended and 100% biomass. This is just for reference, and this just shows that as you can see for 100% coal, the nitrogen content and the sulfur content, atomic content, this is both are less in case of 100% biomass. So basically, if you are firing biomass,
your slide are not visible to us.
My slide is not visible.
Yeah, आप दिख रहे हैं सर, आप दिख रहे हैं, आपका स्क्रीन शेयर नहीं है.
नहीं अब तो दिख रहा है, तो स्क्रीन पे बाकी लोगों को दिख रहा है.
सर स्लाइड इज विजिबल.
Please, sir.
It's okay, sir.
Visible.
Yes, both are visible, sir. Both are visible.
Respected sir, मुझे लग रहा है एक बार आप एक बार रीस्टार्ट करके देख लीजिए, मे बी रीजॉइन करके देख लीजिए.
Visible.
Okay, great. Now it's full screen again.
Yes, sir.
Yes.
Yes, sir.
Okay.
Yeah.
Yes, sir.
Okay, then let's come back to the topic again. So what I was trying to prove in with this slide is that the nitrogen and atomic nitrogen content and the sulfur content in the coal and in the biomass. In biomass, you can see it is less. So if we are blending any amount of biomass, we are basically contributing less amount of sulfur dioxide into the atmosphere. So less sulfur dioxide, less nitrogen dioxide and NOx content. This also helps in the environment also. And we are helping in greenhouse reduction gas, which we all know that is also happening if we are blending for any amount of blending is helping in that. So what our Nitra wing was did was it did the combustion analysis of the biomass sample. So what first point which they got was that volatile matter in the biomass, it starts releasing at 200 degrees Celsius. So volatile matter which is present in the biomass, we know that it is 67-65% of volatile matter is present. So it starts releasing at 200 degrees Celsius. While in case of coal, it start releasing beyond 380 degrees Celsius. So beyond 300 degrees Celsius. So we know that as an operation engineer, what we do is around mill inlet temperature. That is the cause of concern. Because if I am keeping my mill inlet temperature greater than 200 degrees Celsius, there is a chance that my volatile matter present in the biomass might get released, or will definitely get released beyond 220 degrees Celsius. Then it might lead to, if it get the ignition temperature, it will lead to fire in itself, in the mill itself, in the coal pipe itself, which we don't want as an engineer, as a desk engineer, as a unit controller. We don't want that. So this was the cause of the concern, and this all required that we need to keep the mill inlet temperature below 200 degrees Celsius if we don't want any fire to happen in the mill. Now, second thing was we know that volatile matter content in the coal, it start releasing at 300 degrees and it completely burns at 380 degrees. The samples of 100% biomass, 10% biomass and 5% biomass, they completely burn, and they burn basically faster. They burn faster because there is high volatile matter content in biomass. So if we are blending the biomass, basically then we are increasing the volatile matter content of the whole sample itself. It is leading to the faster burning of the coal sample itself. And also the premium cause of concern of also, if we know that when we burn any fuel, the ash content which is left behind, that is also a cause of concern. That ash content should not be such that it is hampering my boiler, it is depositing in the boiler. So with 10% blending, this was also observed that it is not hampering any water wall tubes or superheater tubes or anything like that. So it was not a matter of concern that it would affect our boiler in terms of ash deposition or ash lighting point increase. So the basic rough operating procedures which we deduce from this analysis was that we have to keep the mill inlet temperature at 180 degrees Celsius. On a safer side, we kept the mill inlet temperature at 180 degrees Celsius. So because we don't want any volatile matter to release in the mill itself while during pulverization. And then as we know that the biomass burns faster with respect to coal, it was suggested to keep the lower mills in service like C, D, E. Suppose if there are 6 mills A, B, C, D, E, F, we tried to first started firing in the bottom mill C, D, E. So that if it is burning faster, then it will help in. We had some apprehension that it will lead to reduction in our superheated temperatures, or it will lead to reduction in superheated temperature, but it didn't happen so, which I'll share our observations in the subsequent slides also. Then expected higher water wall temperature, as I mentioned that the biomass burns and releases heat faster with respect to coal, it was expected that water wall temperature will be higher. But it was just slightly higher. It didn't hamper out any boiler parameters or any superheated temperatures, which I'm going to show in the subsequent slides also. Then what did the operating procedures modification was done was when we were charging our biomass firing for the first time, we basically, first point is very important, we serviced our service in a steam inerting valve. We all know as an operation engineer, just to breathe, a steam inerting valve, in case of any mill fire, there is a valve provided of steam dumping in the mill to prevent, to stop any fire from happening in case if fire has happened. To stop the fire from spreading, we use steam inerting, and that source of steam inerting is mostly ox BRDS, which is present in our boiler units. So now that steam inerting valve, since we were firing coal, so that valves were mostly redundant and they were not in the operable condition. So before firing these blended mixture, we serviced our steam inerting valve, and we also provided one motorized valve also in the series of that. Earlier, the provision and the earlier drawing of 210 megawatt and 500 megawatt, the units are provided by BHEL. So earlier design was that there was only local manual valve which was provided near the mill. With individual mill, there was one manual valve which was provided. So in case of any mill fire, we used to open that valve, and then a mill fire can be stopped. But since it was decided to fire biomass, so that to make ease for the operation engineers, as a motorized inerting valve was also provided in the control room itself, and its operation was provided in the desk. So in case of any mill fire, that valve could be opened from the control room, and then mill fire could be stopped. So that was a prerequisite before firing any co-firing, any blended fuel. That is the prerequisite. Even now also, after 7 years of firing, I would like to share that if I am going to know that in my C mill, my suppose in my if CHP is informing me that in आपके C bunker में we are feeding the blended mixture. So what I'll make sure is that my steam inerting wall line should be charged till the motorized wall. My manual wall should be open, and the motorized wall should be operatable from the remote itself. That I need to check from the electrical side also, that we make sure. Then when it was fired for the first time, we took an extra precaution. We deployed fire hose, and fire tender were also made ready, because we were all apprehensive that whether any mill fire would happen or not, means it won't lead to any firing instances. Then modulation control for hot air damper and cold air damper was also provided. This is the part where logic comes into play. We all know that if we fire fuel in the mill, whatever the amount of air which is being decided is decided by the hot air damper, and my outlet temperature of the mill is being controlled by cold air damper. Suppose if my outlet temperature, if I am keeping at 80 degree, then my cold air damper opens according to the requirement, and mill outlet temperature will remain 80 degree. But now my main point is not to maintain the mill outlet temperature. My main point is basically to maintain the mill inlet temperature, as we have seen in the previous slide, that we need to control the mill inlet temperature below 200 degrees Celsius. So what we did was that with the help of our C&I team, the logic was modified. Now the cold air damper was made to operate on the basis of taking inputs from the mill inlet temperature. Then there were different alarms which were provided in the mill UCB, and they were just for the timely action of operation engineers. So if any mill is being selected into biomass mode, then if there is a mill outlet temperature greater than 70 degree, there is an alarm. If there is increase in mill inlet temperature, there is an alarm. So there are different alarms also provided, and also there were 4 different types of temperatures, 4 temperature sensors which are provided in the different coal pipes also. In the tangential firing, a mill provides there are 4 different pipes which goes to every corner of a boiler basically. So at different pipes, in each and every pipe there was one temperature sensor also was provided to monitor whether हमारे coal pipe में आग तो नहीं लग रही, whether there is no fire incidents in our coal pipe. That was also provided. Now this is the mimic. What I have told, this is the max DNA mimic which is provided in our control room. So this is a mill page, basically mill Delhi page, as you can see, coal D. In our terminology we say D for Delhi. So this is the mill. These are the 4 temperature points which were additionally provided to monitor the coal pipe temperatures. And this is the inerting valve which I was talking about. This is the motorized valve which is being provided additionally in the mills which we readied for biomass firing. Now, as this was all about the SOP, so whenever we get any consignment, our chemistry department basically receives the pellets and basically takes the sample, and it measures the GCV and the moisture, and then on the basis of if it is in the acceptance rate, we get to receive that sample, and then the sample is sent to our CHP yard. From CHP yard, basically it sorry. So what we did was how to do blending. That's also a major question, because now there was a separate copper which was previously not used. That was used to store the your biomass, and with the help of this rack and pinion arrangement, the opening of this gate allowed us to drop that much amount of biomass which we wanted to blend. So basically you can say it's a rough
अच्छा वीरेंद्र जी
estimate amount of things,
आपको
but
ही मैं ये
we
वाला
try
दूंगी
to put it
जो
in that
फैकल्टी
way
ज्वाइन
only.
किया है डीडी जी के भाई हॉस्टल 1 में कोई रूम
So
खाली है कि
we
नहीं आप बता
basically
दीजिए
did
तब
the
जाके
blending
उसको
for
हॉस्टल वार्डन
5%
के हिसाब से वही
initially.
देना है उसको वार्डन बनाना
So
है तो
there
वही
was a
देना
track
है
hopper from there coal was being carried and lifted to the transfer point. That transfer point is basically this one only. Below this conveyor belt is going for the coal, and above that we are just feeding the biomass over it. And from reclaim hopper, the biomass is being fed to the transfer point. And from transfer point, the blended fuel is being sent to the coal vectors. So this is the hopper which we have seen. ये disturbance.
सुनो वो लोगों को जो टैली लोड करना है ना हम
This is
बोले
the
वो लंच
hopper
टाइम में
which we
करेंगे
are
अभी
talking
खाली
about.
नहीं है
When we receive the pellets, this is how manually they are unloaded over this hopper. But now the truck tippler has been installed in NTPC Dadri because this has become a regular phenomena, receiving of pallets. So this is not being done manually now. So these pictures are for the first time how it was blended. So we received the sample, then it was collected in the hopper just lying below this. I'm really sorry. This is the blended mixture which is being carried by the conveyor to the bunkers. Now, for the firing for the first time, we made sure that the mill outlet temperature should be in the range of 60 to 65 degree. Mill inlet temperature should not be more than 180 degree, as I have mentioned. The PA header pressure was kept slightly higher. Normally in our mill, it is recommended around 740 to 760 mm of water column. So we maintain the PA header pressure, the primary air pressure, that air which is required to basically that removes the moisture from the coal and which carries the air, which carries the fuel to the boiler itself. That is the PA air, primary air. Now that pressure was kept slightly higher because we were apprehensive that कि हमारा fuel उठेगा मिल से कि नहीं उठेगा. And then pre-start and post-shutdown purging of the mill was also made mandatory, and all the mill parameters were being monitored on a continuous basis. Now, last line is very important because we made sure that mill inlet temperature should not go beyond 180 degrees Celsius. Just to make you aware that earlier there was only one point which was available as mill inlet temperature. So, for increasing the redundancy, another point was also provided in the mill inlet temperature. So there were two different points from where our PID controller was taking the command. Mill reject system was also kept ready and it was kept under observation. Then local operator was also deployed. In case of fire also we had prepared some SOP कि अगर आग लग जाए, in case अगर हम पहली बार जब fire करें, अगर आग लग जाए तो क्या करें? But to make you assure that in the last 6 to 7 years of our co-firing of biomass with fuel, no fire incidents has been reported till now. Now, fire tender was also deputed, and then the flue gas temperature was also monitored in the superheated zone, and then clinkering and slagging tendency was also monitored with the help of local peoples also, and with the help of bottom de-ashing time also. We were and soot doors and LRSB also was kept ready. In case if there is any deposition of soot, so we should be prepared for anything. This is all which we are talking about when we were charging it for the first time. But now, if the things have become much more simpler, this is what just all the apprehension which you all must be having. कि अगर हम अपने boiler में fire करेंगे first time, then how our boiler is going to react. This is just to share the views. Then whatever the observation was, इसका कोई एक performance log हमने तैयार किया था. We prepared the performance log. And that unburned carbon in the bottom and the fly ash was also tested. Then effect of co-firing on SPM or particular method, the SOx and NOx is also monitored. The evacuation time of fly ash and bottom ash was also recorded just to make sure that it is not affecting our routine operations. And then mill rejectant classifier was also checked that कि कहीं ऐसा तो नहीं कि if we are pulverizing biomass along with coal, it is affecting our mill. So this is the timeline which we did in the 2017. It was done in 3 phases, as I have mentioned, 5, 7% and 10% of blending. In 2018, we started the commercial co-firing of biomass at NTPC Dadri, and in 2020 we started biomass firing for the first time in the 500 megawatt also units. Now all the 6 units are ready for biomass firing. Now, the point which I wanted to prove in this was this. This is the important page which I wanted to show you, that before firing any, before feeding any bunker fuel in blended fuel in the unit, coal handling plant. This is a coordination thing which happens. This is a report of 21st January which is being shared. So as you can see, we get the report from our CHP department, coal handling plant, that the biomass is being fed in this specific bunker. So as you can see, earlier the bunker level was 10 meter. With the blended fuel, it is being at 5 meter level. So total fuel is being fed is 600 metric ton. Out of that, 550 tons is around coal and 50 tons is your biomass. So it is a blending of around 8.40% in that specific bunker itself. So this is the log sheet which we get from the CHP, that this is being fed. So earlier, which the mill, suppose if this we are talking about 5F mill. So if in this mill earlier it used to be run on the normal mode, we change that mode to the biomass mode as soon as कि हमारा biomass जैसे ही आने लगेगा. Now, how do we get to know that biomass has come? Because we all know that bunker height is around 24 meters. So below 10 meter it is purely coal, and above 10 meter it is around 10 to 5 meters. When we talk about going from the top, it is blended fuel. So that is very important. For that also we did the modification. We provided view glasses. There are view glasses. Earlier also there were view glasses in the feeder itself. So from the feeder panel also we get to feeder local panel. The local operator gets to know that okay, a blended fuel आ चुके हैं, अब आप इसको biomass mode में change कर दीजिए. And from the also from the local operator, and also as an operation engineer, desk engineer, I know that 10 meters को खाली होने में कितना time लगेगा. Then subsequently I can switch that mode from biomass to non-biomass to biomass mode. When I talk about biomass mode, non-biomass mode, this we'll see in the coming slide what I'm telling you about. Now that how to know that my blended fuel has arrived in my feeder. Now that is very important. Now for that there are different view classes which are provided in the feeder panel itself. Now if they get dirty, there is a provision of service air also being provided in the feeder panel. With the opening of that air, it helps in cleaning of the view classes from the inside. There is a bulb also which is being provided in the feeder. That electrical supply of that bulb is also ensured during the mill and feeder PM. So that क्योंकि अगर अंदर feeder की light जल रही होगी, then we get to easily know that blended fuel has arrived or not by viewing at the view class. These are the steps which we take to know whether blended fuel has arrived in the feeder or not. Now this is again the same thing that we try to maintain the mill outlet temperature around 60 degrees Celsius, greater than 60 but not beyond 70 degree. Mill inlet temperature not more than 185. This is something which we have discussed. Now this is the screen which I was talking about. As you can see that this is the OWS mimic. This is the hot air damper and cold air damper. This left one is the hot air damper which is showing, and this is the right air damper. This right one is the cold air damper. Now hot air dampers, the opening of hot air damper depends upon the mill feeding. अगर आप 20 ton feed कर रहे हैं, then the airflow will be decided by the curve around 20 tons. If you are feeding 30 tons, then the airflow will be decided according to the curve. That comes from the logic itself. Now what is important over here is that mill's cold air damper is taking control from two modes. One is the mill outlet temperature and one mill inlet temperature. Now during non-biomass mode, when the biomass is off, as you can see right now, the temperature which cold air damper is governing is the mill outlet temperature, which we all run right now also with how we run the mill. But in case of biomass being on, the governing parameter for this cold air damper comes to be this mill inlet temperature. As you can see, there are two mill inlet temperature which are being provided. As I have told that there are two different points just to increase the redundancy. So as soon as this biomass on mill, I select that this takes the input parameter from the mill inlet temperature. Now I set that mill inlet temperature to around 180 degree, 182, 183, not more than 185, anything less than 185, 180 degree. So this is how we select the biomass mode on and off. This biomass mode on and off is being selected when HAD and CAD are in manual. Once we select that, we fine tune the parameters. We put that in our system in our auto. Now this is the procedure, how to change over to biomass mode on and off mode. So put the CAD and HAD to manual mode as I have mentioned. Ensure the set value of the mill inlet temperature to 170 and 175 degree. Now this makes sure that biomass on pop-up will get on only when the mill inlet temperature is less than 175 degrees. Suppose if mill inlet temperature is 200 degrees and someone accidentally puts on biomass mode on, then this button will not get on. The permissive of this button getting on is that this mill inlet temperature should be less than 175 degrees. These are all the permissive which are provided for the ease of operation engineers. One protection is also provided. The protection is that in case the mill inlet temperature reaches beyond your 195 degree, the hot air gate closes. Now the earlier protection which was there in the mill, which we all know, that in case our mill outlet temperature goes beyond 95 or 105 degree, different segment in different units, तो hot air gate बंद हो जाता था. But now currently in this setup, the protection has, if you select the biomass mode on, the protection switches to hot air gate from the mill inlet temperature. So if mill inlet temperature goes beyond 190 degree, then the hot air gate will get closed. So once we have brought the mill inlet temperature to 175, 170 degree, we can put the biomass mode on and then put the CAD and HAD in auto with the respective set point. Now the mill cold air damper will shift to mill inlet temperature, and we can bring the decide mill outlet temperature according to the mill loading. Suppose if mill outlet temperature comes जा रहा है, then we can decrease our mill loading and increase our mill outlet temperature. Now these are some of the do's and don'ts. These are something in case of agar fire lag jata hai, there are some certain standard of SOPs which we all have developed in our plant regarding firing of biomass. So if these are the SOPs, do's and don'ts which we have made in case of NPTI Durgapur, that agar kisi mill mein aag lag jata hai, call the CSF personnel or the fire wing, whichever is present in your plant. Increase the feeder speed to maximum so that we are dumping the fuel. Stop the feeder after few minutes, then close hot air gate from the control room and cold air gate. We won't supply any air because providing any amount of cold air or hot air will lead to basically providing the oxygen to the fuel which is already under fire. So अगर फिर भी नहीं control हो रहा, then we admit our steam inerting, open the steam inerting valve and dump the steam. But this is just for in case of last step, last resort. But as I have told you, in our 7 years of co-firing, no such incidents has happened. Of fire has happened in the Dadri plant. So this is the tippler which we was called truck tippler, which we were talking about this. As we receive biomass, you can just tipple this. Sir, आपका किसी का mic on है, please एक बार ऑफ कर लीजिएगा. Thank you so much. This is how biomass receive होता है, उसका sample होता है, and this is how unload होता है. This is how the biomass sample is stored. As I have told you that this is hygroscopic in nature. This is the previous year storage of biomass pellets, but now a shed has been created to store the biomass pellets at Dadri itself. I hope my presentation ends over here. Thank you so much for listening it patiently.
Many queries, sir.
Hello.
Yes.
Good afternoon, Rohit ji.
Good afternoon, ji.
सर एक क्वेरी थी मुझे.
हाँ जी बताइए.
ये सर जहाँ स्टोरेज होता है, फायर प्रोटेक्शन सिस्टम का क्या अरेंजमेंट है सर?
Hello.
हेलो
Hello.
हेलो
Hello. Hello, Rohit ji.
हाँ जी.
At what temperature rise rate you have provided the alarm? Mean temperature rise rate At what value you have provided the alarm?
It's not right rate. There is no alarm at rise rate. There is an alarm at 180, more than 185 degree. There is a first alarm, and beyond 195 degree, the hot air gate will close. These are the temperature points on which protection and alarm has
Now,
been put. And without
is there any
greater than 70 degree.
okay? Man, is there any temperature rise in respect of time, such as per second, per minute?
No, there is no alarm as such on rate of rise.
Sir, kindly put your video on, sir.
Rohit sir.
Rohit sir.
Okay.
Hello.
And the second question.
Wait, just a sec, sir. I take that question. Just a second, ma'am. I would like to ask: do I have any time to show some video of 8 minutes? Do I have that time, or I don't have any time?
Sir, actually we are running short of time now, so I would like to inform all the participants to please keep their questions ready. We have a question answer session just before the lunchtime after the next presenter. I think that will be a very formal way of addressing and taking up the questions. So the participants can just keep the questions ready, sir.
Okay, sure. Thank you, ma'am. Just as a last line, I am sharing a YouTube video link in your chat section itself. So I request each and everyone. That's a short video of how the samples are received at NTPC Dadri, how basically they are sampled, and how we are going. Basically, they are sent to the boiler itself. That's a basic. Just in the video form, we usually get to understand things very easily. So I'd share that link, and please kindly see whenever you get the time. Thank you so much, ma'am. Thank you so much.
We thank Mr. Rohit Grover for explaining elaborately on the biomass co-firing and sharing their experiences of NTPC Dadri in co-firing with biomass pellets. And I think the participants working in the power plants have got an extensive understanding on the detailed parameters that are to be watched and to be kept, and very important, most important for the operational engineers. So thank you, Rohit sir. And I would again like to repeat that we have a question answer session just after this session is over. So kindly all the participants keep ready with their questions, and we are very much interested to take as many questions as possible, so that the faculty present over here can clear your doubts, and this will give a real objective to this program also. So now may I invite Shri Dr. Sarvanand Bhavan, who is an expert from the heat exchange group, and he is an international the speaker from the UK. Sir, please welcome on this forum, sir. Are we having Dr. Sarvanand with us? Phone kariye unko. ठीक है. वो है कहाँ? ये वाला. ठीक है.
इनका स्पेलिंग में बी नहीं लिखा कल
बी है तो यहाँ पर
वो अलग, फिर बी सामने दो बार.
सर हमें मान लीजिए सर आए नहीं सर प्रेजेंट करने के लिए दूसरा फोटो लीजिए सर, जूम मत कीजिए,
जूम नहीं करते, ऐसे ही करते.
ऐसे लीजिए, उसमें हम लोग क्रॉप करके काटेंगे, सही रहेगा, जूम कर जाएगा सर. जाइए.
Dr. Sarvanand, are you on the line, sir? उनका फोन म्यूट है, वो बोल रहे हैं.
Yeah. Now it's okay. Can you hear me?
Yes, sir. We can hear you.
Okay. That's great. Thank you, madam, for your opportunity for providing this presentation. In my presentation, I would like to cover a few things about my experience in the biomass.
Sir,
I have started in
sir, sorry
2007. When I was
sir, sorry for interrupting you. Can we have your video, sir?
I put my video, but I don't know really. Yeah.
Yeah, now it is perfect, sir.
Yeah. Okay. Thank you.
इधर आया नहीं, बड़ा स्क्रीन नहीं आया.
I'll just share my presentation.
Sir, can you speak a little bit louder?
Yeah. Can you see my video screen?
Yeah, we are able to see you, sir.
No, my videos. I mean, my PowerPoint screen.
Yes, sir. Yes. Not yet.
Okay. Yeah. Just 1 minute. Sorry for this technical issues. I will sort it out.
Sir, we can see your screen. Please carry on. Start with the presentation.
Okay, right. Because in the main screen, it comes my photo, but I wanted to share my screen, my PowerPoint presentation.
Either.
Sir, you will have to share your PowerPoint presentation to the live stream.
That's what I'm doing. Yeah. Just 1 minute.
Sir, you have to reshare your entire screen, not only tab.
Oh yeah. Okay, I'll do that. This kind of a storm here in the UK, so my internet connection is a bit slower today.
Sir, full screen, please.
Sir, could you please put it on the presentation mode?
Yeah, I put it that way. I have two screens, so I put now you can see my screen.
Not yet, sir. You have to reshare your screen, sir.
Can you now?
Yes, sir. Now it is.
Yes.
Yes, sir.
Okay.
Yes, sir.
Okay, that's great. Sorry for the technical glitch a little bit. In the co-firing biomass, it's not new for me. It was, when I was joining in 2007 for the UK company called Alstom Power. My, major work was to blend the biomass.
Excuse me, sir.
Yeah, can you hear me?
Yes, sir. Yeah, you are hearing, sir. Please hide that slide. Tap. Only hide. Okay.
Yeah.
Okay, sir. Carry on.
Yeah.
Carry on.
Okay. Sorry, I was seeing my other screen. So, so I was started with the co-firing of biomass. That time it was planned that biomass is considered as a carbon neutral fuel, and UK government was interested to go for decarbonization of the coal power plants, and then they have decided that it is not possible only by blending of the coal, so they have taken out some of the coal plants. So all those things I'm planning to explain, and how my experiences come across with respect to the excuse me, UK government experience on the energy. In my presentation, I cover the 5 important aspects. One is the overview of the UK power generation, because some of the Indian participants may not be able to, aware or appreciate the UK system. So I just wanted to add it. And then I will cover the biomass co-firing, what are the available technologies, and what are the issues, and what are the remedies for those things, and applications of the biomass in the UK, how it has been done, and what I can recommend for the India, based on this experience. If you see this, the power, the biomass co-firing is considered as a promising general a new option. That was the case. It was mentioned in 2011, and now in India this is coming up with 2022. So we are slightly delay in these kind of processes, but of course, as my previous presentation presenter Mr. Rohit Grover explained, they have already started working on in various testing ranges, and these tests are coming into the system. So this in the background of the plant, if you can see that this is a plant where the typical UK power plant it will be looking like, and the areas are like that. So now you can think about the plant in the UK and how it can be compared with the coal-fired plants in the India. So when I first visited here, I was really surprised because I visited many plants, especially I visited NTPC Badapur for a couple of times during my tenure at NPTI Faridabad. So I could feel that the housekeeping and other practices are much better in the UK because they are legally to do so. And when we come to the UK power generation, now actually the UK power generation is slightly in a mess. I will cover it a bit late. The installed capacity is something like around 60 to 70,000. That's the range. It's normally in that. And if you see from 1996 to 2020, the increase is from 70,000 to say 80,000 nearby, but it never been increased beyond that. But if you consider the same period from 1996 to the 2020, India has almost tripled its power generation. In 1996, it was less than 100k installed capacity, whereas I think nowadays it reaches more than 350k megawatt kind of power generation. So India's growth is tremendous in this period. And if you see the coal fired from 1996, which is covered in this graph, it was initially about 25,000, roughly about 25,000 megawatt. And now in 2020, I don't have the data of 2022. I mean, I have data, but it's not complete in a sense because it's not completely running on full time. So it's not a base load anymore. So it's hardly about 4,000 megawatt. So there is a big reduction in this power generation through the coal has happened, and oil fired it has always been thin and it is almost virtually none. Gas fired power generation on the other hand, it increases from say nearly about 12,000 megawatt to now it's about roughly about 35,000 megawatt range. So we have increased in the natural gas fired based productions, and there are some mixed and dual fuel where the 2007 this actually the biomass fired and other things have come in, but now it has been reduced and it has come down into a very, very low level of that. And nuclear is provided almost similar but not much. Hydro is also the same. And if you see here, there are some offshore wind and wave and all those things are coming, and these are relatively low. But if you consider the actual power generation, it was happened with last night. I just checked with the grid what is happening here. You can see here it was around 9 yesterday night around 11:45 UK time. The total load was about 26,000 megawatt, and out of which the renewables provide 37% and carbon neutral fuels 51%. So these values, if you see here, you can find about 80, more than 90%. It is something related to the carbon neutral fuel. So the real coal and other things have been considerably reduced. I provided a link here. If you click here, it provides the latest power generation, and if you want to see that, that's available here. I can share you on the screen. So this is the latest one, and now it's live. So, about 6:40. I just checked that. Now it can go with every 10 minutes and something like that. So it's about 28.5 megawatt, out of which the wind is actually providing about 41%. So night it was 27%. Now it's actually 41%. Okay. So there is a big difference in this, and the coal is actually is coming down. Currently, only there are 3 coal power stations are in operations. One is West Burton and Radcliffe on Soar and Kilroot Power. And this year, the West Burton will be closed, and next year Kilroot will be closed, and in September 2024, Radcliffe Power will be closed. So all the power generation will be closed by 2024, which was planned by the government by 2025. So they are closing 1 year ahead of the plan. And in this period, when they are closing, you might have seen the biomass. It's actually increased from almost nil to about 7,000 megawatt. So that's the kind of power biomass power generation is is picking up. This is this blue curve. You can find it out. So from 2005 it was virtually none. Now it is almost reaching more than 7,000 megawatt. If you consider the renewable sources, where the main sources are coming from, the power actually provided by mixed fuel and dual fuel, which is diminishing, and the pumped storage, which are almost same, and bioenergy and other waste, which are increasing, and the offshore wind has tremendously increased now, and wave and tidal is also picking up in a way, so that the power generation is now more or less towards the renewable base. And the biomass alone yesterday night was about 8% that contributes the grid. In the electricity supply, the base is coming from the installed capacity is 53% wind, and the available generation is 50%. In some of the cases, it even reaches as high as 66%. Nowadays, it has been increased, and the co-firing is contributing about 20% of the generation. This is the scenario of the UK, but the problem now is, since we are majorly depending on the wind and the natural gas, sometimes the wind was creating an issue here, and our power generation gets affected, so it needs to be fulfilled by natural gas, whereas natural gas, we need to get it imported from elsewhere, and the political situations in Ukraine and Russia and elsewhere, that has been severely affected, and all the power plants in the UK have been almost privatized, and because of that, no other privatization companies would ready to invest on the energy. So the thing is, like, in the future, if any energy increase happens, then the UK government would be really in trouble for meeting this power generation. On the other hand, being the end user, the people, those who are paying for the bills, it has been controlled by a government organization called Ofgem, and the Ofgem is controlling the prices, and they put some kind of limits on the rising of the price. Because of that, this year and last year, many power supplying companies have gone bankrupt, and only few companies are working. And recently they have increased the power prices by almost 60 to 70%, and it is expected that it will be increased further. So the power generation cost or the power providing cost is almost doubled. So the people are feeling some kind of a trouble because of this higher increase within a year. So people need to pay for what they pay for, and they almost double their prices. So this is not the sustainable way of the pricing policy, but this is the situation in the UK now. So living ahead of that, so we need to learn from the UK's mistakes, and when we wanted to do some privatization in India and all, it needs to be applied very carefully. Leaving aside this power generation scenario, I would like to come back to the co-firing. And in the UK, the co-firing technologies, there are more or less there are two types. One is the direct firing, and another is indirect firing. In the direct firing, what people used to do is they have to fire the biomass, and I will come to know. I will come in the next slide how to explain this. And co-firing, the dedicated co-firing to dedicated firing is happening. That means there is no biomass mixed with the coal. It is 100% biomass. So that's the thing. It is happening here. In the biomass co-firing, I think the previous presenters and in the afternoon presenters, they are going to talk more about in detail. But I'm just giving you an overview of all the technologies. In the direct milling, the coal is actually fed from the bunker and the biomass without any process or with a limited process passed into the coal milling, which the the NTPC's Mr. Rover actually shown that. So they have mixed up about 5% range maximum into the same milling, and they may identify one mill which is the mixing one for that out of the 6 or 7 mills in the process, and then they pass through the coal burner, and the same burner, whatever it is available, the fuel is passed and sent it into the boiler for combustion. So that's the direct milling. And there is a direct co-firing. What happens is the biomass is fed into a separate milling process, and coal is milled into a separate milling process, and then all mixed into a burner, a dedicated biomass burner, which is designed for that. And with that burner, with the help of that burner, it is combusted in the boiler. In the dedicated biomass co-firing, normally the biomass firing, and there is another dedicated burner that is exclusively burning for the biomass, that will also be placed in the boiler. And the coal milling process, whatever that existing, it is there with the same thing with the dedicated for coal burner, that will be passed into the burner for firing. So in that way, the coal milling process and burning process are separate, and the biomass milling and biomass supplying process are separate. So these two things are separately considered. The next step is why we should use the coal. So they have stopped the coal, and they've stopped the coal kind of thing. They've increased the number of burners, and they've considered the biomass milling, and that milling is used for 100% biomass. So this is the dedicated biomass burning. I have worked on co-firing and dedicated wiring, and mixed all the three varieties in various projects in the UK. And the main thing is, when you are doing for this firing, the main plant considerations are either doing the retrofitting of the existing plant, or if you are going for the new one, consider for the new plant, and what are the importance that you need to consider, and what are the things that it needs to be applied, or the lists. And these plants, if you are going for retrofitting, these plants are cheaper because you are doing a very limited kind of modifications. However, you cannot completely design it, so you need to have some limitations of co-firing. People say about 5% to 20%, which is the normal range for the mixing of the biomass in the existing thing. And with this plan, we can do the quick turnaround, and for which all you need is you need to have a biomass characterization based on the biomass which you are going to combust, and you need to design your biomass burner, and then you need to apply that into the system for the integration. There are some requirements in the heat transfer materials, like your membrane balls and superheaters, reheaters, and these materials are supposedly capable of withstanding when you're firing the biomass, because some of the nasty materials present in the biomass would be harmful for the plant life. So what we did was we arranged a biomass co-firing from 5% to 20%. We applied various materials arranged in a kind of a heat transfer path, and we applied a dedicated kind of a mechanism where these coupons are arranged with smaller sizes of various materials, ranging from carbon steel to low carbon alloy steels and high alloy steels and like that, and how they've affected over the period of 500 to 2000 operating hours. Actually, our plan, I mean, I was involved in a research where we have almost run for 2 years, where the total plant running was about 6,000 hours. And we have taken the coupons at intermittent intervals, and we have taken the coupons modifications for the biomass combustion, and we have collaborated with the biomass characteristics and identify which material is suitable for long run of operations. That kind of approach we have done, and it was practiced by major companies all over the world for the boiler to provide conditions. And then the feeding system modifications, controls and instrumentations need some tuning, as disposal systems is slightly different because biomass has a lot of unburned systems if it is not properly combusted. So the ash which properly used earlier, that needs to be tuned to these biomass characteristics. There are few environmental concerns that also have been addressed, and the thing is, like, with this kind of systems, the availability is very, very limited. Whereas if you are going for the new plant, it is an increased cost, a new layout, and which material it needs to be to fit the biomass. So you provide the new burners, new biomass storage, apply all the environmental standards, and as disposal systems are unique for that, and viability of long term. The only thing with this new plant is you need to ensure that the viability of long term biomass availability. I will explain this, why this is very important in the next few slides. And the biomass co-firing issues are, the biomass sourcing is one of the things, which is, I mean, there are two, I put it in, one is the outside of the plant, what are the issues, and what are the things which are within the plant. One is the sourcing is the problem, and another one is the availability and transportation is the problem. If you consider the sourcing elsewhere and transport it from elsewhere, it may fit into your economical conditions, and that would be affecting the financial efficiency. I will explain how the UK government and the UK plant operators are managing this with the mechanisms. I will come back in next few slides. Within the plant, you have design issues, like whether the existing plant is capable of burning the suitable biomass, or what are the fuel characteristics, what are the effects on thermal and mechanical, is it possible for retrofitting the existing plant? If it's possible, then how much it will cost, and what are the additional disposal systems that needs to be covered for. And the biomass co-firing, the engineering capabilities any country needed is, you need to apply proper due diligence, you need to identify the fuel source, you need to execute long-term fuel supply contracts, and how it is being applicable for the existing stations, because that needs to be studied, and you need to have a hazard operability study when you are working on this biomass. What are the additional issues you have to maintain for keeping the plant safe, and the people are safe working in the plant. And you need to provide additional layouts to accommodate the biomass storage and transfer, installation and commissioning, and you have to have some proper asset management of this biomass utilities, and these are very common for all the coal-fired plants, but we need to apply specifically for the biomass as well. And the next step was, people are thinking of using the biomass and waste. If it's possible, we can use it together. And what are the technologies which are available if they are going for dedicated biomass? And if we consider the combustion, which is the normal power generation in India, we do. And there are other processes like pyrolysis, gasification, and biogas generations, and they are also possible in biomass. In India, this biogas generation using animal, manure and other things is a kind of long back story, and that's the part of the biogas generation which fulfills that. And the gasification and pyrolysis technologies are yet to be developed, or not much involved in the Indian environment. Whereas in the UK, some of the plants are pyrolysis plants which are working, and I personally work with few plants which are on the gasification mode. They provided, they in the gasification plant, the same thing. The biomass is subjected to high temperature advanced gasification technologies, where the gas contains majorly of methane, and that gas is combusted in a burner in the boiler, and that from that the heat is actually generated. So with this one, the process is more clean, and it's more efficient, and it's additional gasification technologies are needed instead of the direct biomass, but that is more efficient, and you can segregate the waste, and the biomass plants, the boiler plants are capable of running with longer time. Whereas the waste, the same kind of things are applied, but instead of the pyrolysis, it's actually incineration process are applied. And in India, I think we may need to consider for either this kind of biomass gasification and waste gasification technologies that would be more useful for mitigating our biomass and waste resources. In the UK, at the moment, there's one company called Drax Power, and this power, is mainly working on 100% biomass. The UK government running with various programs for decarbonizations, so that their aim is net zero emissions at the end of the day. In the UK, the practices are these are the bins, and each bins and the household biomass are collected. We need to provide it in a green, and that will be collected by the local council on a specific day. They will come and collect it in every house, whatever that left it in a weekly manner, and then they they collect it and they taking it into biomass processing, and sometimes they may go for using this for fertilizer, or sometimes for advanced gasification, or whatever the available methodology. It can be used for better disposed of. If nothing is possible, then they can end up in the landfill. In addition to that, the biomass is actually imported from elsewhere. The government actually provides the systems, like there are some funding mechanisms which are provided. There are direct funding mechanisms and indirect funding mechanisms. The direct funding mechanisms comprises of demonstration, R&D, pre-commercial deployment, and landfill levies. And this landfill levy is the important thing I want to tell you. When the wastes are collected at our home, if it is deposited in the land without any processing, and each ton the collecting company needs to pay about 80 pounds per ton, which is about 8,000 Indian rupees. That means each kilo is costing 8 rupees in India, whereas some places the rice is provided for 1 rupee per kilo. So here the waste itself is costing about 8 rupees. That's the kind of the cost they fix it in for the landfill. So because of that, what happens is the collection companies and other councils, they want to avoid that cost, so that they wanted to avoid the landfill. So it is encouraging in a way. The indirect way the government provides, there is a kind of a renewable obligation certificate. That means if any plant provider who wants to put the plant, he has to first apply, and he has to mention that how many power he wants to supply to the grid, and how much it is coming from the renewable, and each certificates, based on the prices, they will be given some kind of a reward, so that this is in addition to the power selling cost, they may get it in. And the second thing is, like, okay, they provided, but people first agreed, and they are not connecting into the grid that much, but still they made the money. So the government has come up with another solution that is called contract for difference. That means if you are using a renewable plant, and if you are using a non-renewable plant, how much the contractual differences in that cost, and that money will be provided in a phased manner, so that the plant will get some money for their construction. so that it is helpful for them to match with the non-renewable resources. So that's the kind of thing they provide, and this is still existing. The practice renewable obligation certificate scheme is not existing anymore, and feed-in tariff is another one. Like whatever the renewable you are feeding in, say for example, if you have solar power under your roof, and if it is connected to the grid, and how much you are connecting it, based on that you will be given some reward for the money that is called feed-in tariff. Similar to that, if any renewables sent into the grid, they will be rewarded in that. Many power companies, especially wind, offshore wind companies, are making a lot of money out of this. Mainly, the British Petroleum and Shell, and also bigger petroleum companies, they have their own windmill generations because of this, and they are making a lot of money as well. So if you want to know all about the schemes, there are available in the internet. All you need is you need to find out these words, and picking up, these are the documents which are published in the UK government website, which are available. So how the funding mechanisms changed over this. They have the framework called Department of Energy and Climate Change, and they provide some levy and other things. They provide proper documents which are available as a policy documents, and you can get it straight away, and you can apply if you're involving in the business, and you know how much you're getting it power and all sort of thing like that. So the how much it changes from 2011 to that, and it's there. It's not a very latest figure, unfortunately, but the information is available for how much money they are allocating and spending it on every year, and so on. The applications here, as I mentioned, this gasification, pyrolysis, anaerobic. I've worked on few plants with the gasification, worked on few plants on the anaerobic digestion, and I will show you all these things. This is the dedicated biomass, which is the DRAX1, where I involved with the modification of the existing plant to run into 100% biomass. And this is the plant started in 1974 and expanded in about 1980. It was about 4,000 megawatt. Currently about 2,000 megawatts are converted into the dedicated biomass burning, and wood pellets are used in this biomass fuel. But in this interesting part is in 1990, this was privatized, and it was acquired by a company called National Power, and then it has actually later by AES Power Corporation USA, and all these companies have gone bankrupt in the meantime in 2003, and then all the investors in that previous AES Power Corporations and all, they formed a kind of a company, and they started this company called Drax Power, so that this power is now owned by many institutional investors, majorly the pension fund providers, and since then they try to cover that with different technologies, and different emission control technologies have applied, like flue gas desulfurization, FOBA, and all sort of thing, boosted over fire air that is needed for conversion into the coal with NOx reductions. And then they converted this in 2013, the full dedicated biomass firing, and wood pellets are used in this. The interesting part is wood pellets are not available in the UK, so they need to import from elsewhere, and majorly it comes from Canada and USA. And they have a very large storage silo because UK, the climate conditions are very bad at times. It will be always raining, and it's very cold, and it needs to be properly stored. So that's the storage silo which is shown in the figure. Okay, so the Drax power sales is like about, if you see these values in 2021 and 22 and 23, their price is about 51.7 pounds per megawatt hour. If you consider it in Indian rupees, it's about 5,170 Indian rupees per megawatt. You can compare with the Indian cost, then you will know about how much the price difference they are selling it into the grid. And out of which actually they get the fund contract for difference, that is 3.8, and ROC about 10.8, and others 1.3. And if you consider the fixed price is about 15.9, and this price is now coming down to 9.1 and 4.3, and they don't have the contract for difference anymore, and ROC they get very limited, and other sources they get 0.3, but still their average achieved price is 52.7, which I do not corroborate with the figures. So that's why I put this note. But still they are making a lot of money, and their share prices in the markets are reasonably good. If you see how they are getting the biomass and where they are getting it from, this is the slide here, and you can see that this Drax, they import about 37% of the sawmill residues, which are actually the residues of the biomass, majorly from US and Canada, which is about 32%, and remaining 3% they are reporting from elsewhere, and they are getting the branches and tops and other things like that. And again, the major sources, if you consider the European countries, which are Latvia and Estonia and Portugal, and the excluding the Brazil, their total power coming from the Europe is only about 3%. But in reality, they are almost depending on US and Canada and Brazil for their total biomass imports. So what they've done is they have companies in US and Canada for generating the pellets, and these pellets are manufactured and then transported via ship, sea to the UK, and then from the port it is actually transported by the train, which I have shown in the previous slides, like Drax train. So that is the kind of arrangements they do. So this is not a viable option for India. Like, you cannot think of importing from elsewhere and use it in India for the biomass, because it's for me, I would consider that it's not going to be a viable option in a long run. Biomass captive power plants have come up. It is similar to that which I have shown in this slide, where the biomass is actually fit into that, similar to the waste, and these biomass waste are fed into a combustor where the flue gases are passed, and flue gas cleaning systems are applied, and filters are used for capturing that, and then the pure flue gas without any pollutants are emitted into the atmosphere. And it's exactly same like what the power plant we do. Instead of the fuel from the coal, it is actually combusted with this with the waste or biomass. So this plant is existing in Denmark. This is a plant I visited, and this is a waste to energy plant where they collect the waste from various municipals and develop and store it in this storage area, and that waste semi-dried and dried, and passing it through crane and the lifts, and then they passed into this chute, and this chute the fuel is fed into the boiler, and it's exactly combusted like this, and with the outside with this they generate the steam, and that steam is used for power generation. And this entire plant is built in a city area, and on the top of it there's a park in this plant. But you won't get any smell or anything about that. It's so clean and so nice that the plant is running. Another innovations are anaerobic digestion. As I mentioned, it's not new, but it's in a large scale, and in the large scale there's a digester, and that digesters they use for for the biogas generation, and biomethane is used, and then it is used for power generation or domestic use or whatever that. This is the one plant by one of the waste energy plant located in the UK. The recommendations I would consider based on my thing is, like, you have to think about the most cost-effective mechanism, Otherwise, it would be a bit difficult for long-term sustaining, whether it is direct firing or co-firing or dedicated biomass, whatever that. So the easiest options are direct firing, and the second part is the biomass availability. So here in the UK, there is no biomass available, but it's very limited biomass. I would say so. We can't really sustain without this biomass availability for long periods, and minimize the value added biomass fuel processing. Like if you're going for pelletization, transportation, and all sort of thing, and each process is energy consuming, and overall life cycle cost will be increased, and life cycle energy consumption is also increased. It's not as good as the good carbon neutral that people claim to be, because they have considered only the power generation from their power generation plant and to the grid, but previously there is a lot of other emission factors which are also into consideration, but that was conveniently neglected. That's the case. So it's not the true carbon neutral in a sense. And even if you're using existing biomass by cutting trees and other things, that means you're avoiding oxygen generation by the plants, indirectly carbon dioxide absorption. So it's also not efficient. In the UK, this scenario is completely different from the India, because most of the households, they use biomass for cooking, and some of the biomass will be used as natural fertilizer, and this biomass cooking and things helps for their food security. So but in the UK, people are not using that as a domestic fuel, or they don't use it in any of the other ways. So the UK scenarios cannot be considered completely applied for the India. And the latest energy prices in India, I mean the gas prices and all, the costs are very difficult. So people are turning down again back to cooking through the biomass. But this is an inefficient way, emitting a lot of carbon monoxide, which determines the user's health. Local energy needs are met by biomass as fuel, and that's the important thing. But you need to ensure that when you are applying the biomass, it should be very local as possible, and the cost should be affordable. It should not be the same practice of UK's explanation. All of a sudden, you cannot increase the price by almost 50 to 60%, and there's no certain that it will be stopped further. So people cannot able to make their fuel cost. In the UK, it is a very big problem. So the same problem should be possible in India if we are not applying this properly. And the Indian average plant life is about only 10 years. I'm talking about the thermal power plants. This is the reference by IEA Energy, and they have come up with various data. They come up with this. Whereas in the UK and US and other places, the average life of the average plant is just about 40 years and something. So they close the coal-fired plants, and they are affordable to switch over to others. But we have already, India has already having a lot of infrastructure on the coal-fired, and they are hardly used, so they cannot switch on this very quickly towards the other power generation sources like biomass, because they can't able to make their investment on return. So the economy is in jeopardy if we are doing it. So this was discussed in the latest COP meeting in Glasgow with the Indian ministers, and there was something is going on with that. Adequate, government should be providing this contract for different funds, because the power resourcing companies, power generation companies are putting additional investments for the conversion, and all those CFD funds, whatever the additional investments, that should be shared by government, because they help for meeting the government's requirements for the pollution, as well as reducing the carbon emissions. These are the things I would think I could recommend based on my experience. Thank you. If any questions, you're welcome.
Good afternoon, sir.
Yeah, good afternoon.
I'm speaking from Anpra Thermal Project in Sonbhadra, UP. So is there any practical implementation of the biomass co-firing in the ball tube mills in India?
I don't think so.
Okay, is
I
there any?
don't.
Okay, actually
Yeah.
we are having ball tube mills of steel
Yeah.
industries installed in our BTPS plant.
Yeah.
And we have been recommended to implement this biomass co-firing.
Okay.
So, do you find any kind of technical constraint regarding the parameters, temperatures, and all those in tube mill systems? Because
Actually, yeah, the only thing is like tube mill systems. What I find is like when you're firing, if there is any issue with the generation of the flash or any fire within the systems, that is very difficult to control. That's the only thing I could think about it. But rest of the things, it's possible. If you're mixing it and without grinding or anything, then it's okay. Like you can externally grind it and add it in at the end of the tube mill, then it is possible for you to transport it.
So we have the similar consideration, but actually we are not having any external mechanism to grind the biomass pellets.
Okay.
So we will have to grind the same biomass and the coal in the same mill. So we are also worried about the this kind of high temperature rise of flashing or kind of explosions in our running system.
Yeah. I mean, this can be addressed if you can do a little bit of
We thank
pilot
Dr.
testing.
Saravanan and Bhavan sir for such a wonderful presentation and with lot of examples, and you have described so nicely about the system, and we can understand that you are very well versed and experienced in this system. Sir, now we open this forum for the question answers. If any of the participants, those who have kept their questions ready for the last three presentations, I would request the participants. Please, you can ask any questions now.
Hello, ma'am. Hello.
Rohit Guru, sorry, from NTPC operation point of view.
Hello.
Yes, sir, we can hear you.
Ma'am, what is the grindability index of this pellets and what about the fibers? It is grinded to become powder? This is my question.
50 and above. Qualified.
Can I ask question to Mr. Rohit Global?
Mr.
Yes,
Rohit
please.
Global.
Yes, please. Yes, please. Yes, please.
As you have analyzed coal, blended coal also, is air requirements changed? Have you ever experienced कि पहले normal coal में और blended coal में
I'm sorry, आपकी ना आवाज ब्रेक हो रही है. आपकी ना blended coal और biomass coal में
normally 100% blended with biomass. Is there any requirement change in PA?
No. There is no change in PA. As such, there is no change in PA, and there is no change in another, you can say, pressure also, which we keep in the primary air header. So now we are running at the normal pressure as required by the OEM at around 740, 760 mm of water column. So there is no change required in PA. Now, because during mill overhauling also, mill schedule PM also, we got to know that there is no residue as such left in the mill. That was the apprehension. But as such, we didn't find any. So now we are keeping PA header as a normal earlier, which we used to keep also.
Excuse me, sir. Excuse me. Sir, just a moment. I would request all the participants who are online and joined, please keep yourself, your system on mute so that we can, all the participants can listen to what the faculty has answered.
My second, is there any running, like you take running hours में कुछ difference है, Mr. Rohit?
No. There is no change in mill running hours also. Mill internal liners, all the classifier system also were checked in the schedule PM itself, and there was no damage also found in the mill internal also. So there is no issue as such. The only issue, practical issue, sharing with you, which comes is the mill loading itself. As I have mentioned that since हम mill का loading वो कर देते हैं, temperature कम करते हैं, mill inlet temperature we keep at the lower side. So what it happens as an operational point of view is उसका loading current थोड़ा बढ़ जाता है. So because current and mill outlet temperature एक limiting parameter है मेरे लिए, तो वो मैं loading उस mill की कम रख सकता हूँ. Suppose if at full load अगर मेरे को 3-4 मिल full load में तो ज़्यादा इशू नहीं आता, full load में अगर suppose 500 मेगावाट की बात करूँ तो हो सकता है मुझे एक extra mill चलानी पड़े. On that part we have a loss in efficiency part and that we see currently. And थोड़ा सा furnace exit gas temperature बढ़ जाता है. That is क्योंकि because हम ये जो use कर रहे हैं वो थोड़ी ठंडी use कर रहे हैं. Comparatively lesser temperature we are sending in the mill. So these are the two drawbacks which we face in the mill. Subsequent presentations जो second half में है वो efficiency पे बहुत अच्छे से बहुत ही detail में बताएंगे by our Netra wing ventures. So don't worry about that. That will be shared in the subsequent presentation.
So it's an increase in total auxiliary power consumption, na? Any percentage?
Hello.
Yes.
Not appreciable change in auxiliary power consumption, I would say, but there is obviously positive appreciation. I wouldn't say कि बिल्कुल change नहीं है, but there is a change, but not that much कि observable हो, मतलब बहुत कम APC बढ़ जाता है comparatively.
Mr. Grover, just I'm Sandeep Pal from Bhopal. As you have explained the blending process, are you feeding the meals in a staggered manner? I mean, you were showing that meal 5F, you have given this biomass 5%. So are you feeding the meals in a staggered manner, or all the meals are fed at the same time by this blended coal?
Sanjeev ji, in the NTPC Dadri, we have tested 10%.
Do you have a separate bunker for feeding the biomass pellets?
Just a sec. Just let me answer the first question, sir. This regarding feeding the biomass in this continuous mill. This is being done in continuous mills also. In NTPC Dadri, we tested 210 megawatt at 10% blending in the respective BCDE mill. So it was tested perfectly fine. So there is no issue, but as such we don't get that much amount of biomass that we need to feed that into two different mills. Suppose if I am getting 50 tons or 100 tons, what I would prefer is कि ठीक है 50 tons में एक unit में डाल दूँ, 50 tons दूसरी unit में डाल दूँ, as a CHP, as an operational point of view. Suppose, okay. If I will be getting more and more amount of that, which usually मतलब कभी rare amount में ही आता है, usually अभी जितना आता है एक या दो मिल में suffice हो जाता है. But as such from the operational angle viewpoint, flame stability point of view, we can feed that in the adjacent mill also, so there is no issue from that angle.
And any change in the A damper? I mean the lowermost, bottommost damper?
No.
So flame stability and flame intensity is not an issue with this.
No, not an issue. जो हमें apprehension था, ऐसा उससे flame stability में बिल्कुल भी कोई issue नहीं. As such, क्योंकि volatile matter उसका ज़्यादा है, तो flame intensity मतलब अच्छा ही है. Don't worry, flame intensity पे as in उससे दिक्कत नहीं है. जो एक दिक्कत मैंने अभी previous question में भी share किया था, the issue only remains कि अगर हम जिसमें biomass डाल रहे हैं, उसका loading थोड़ा कम रखना पड़ता है specifically. Suppose if a mill is designed for 60 tons, तो मुझे उसका loading comparatively कम रखना पड़ता है. That all depends because mill inlet temperature मेरा कम हो जाता है. That current of the mill थोड़ा increase हो जाता है comparatively when we compare with 100% coal.
And I suppose no changes in SADC also then? No auxiliary?
No changes in SADC.
Thank you.
Okay, Rohit sir.
Hello, Rohit sir.
Hello. From CSC, if you allow me to ask a question. Just a minute, sir. My question with the number of mills that you are giving 5% or 7% tarified or non-tarified. I think it's non-tarified. You're talking about the bowl mill. So, will you able to achieve the full load?
Yes,
as you have said that the mill throughput is going down. So, if I am putting all the mills with these pellets, the 5 to 7%, does it make allow to go for full load?
Debashish ji, sir, if we have to go for full load and if all the mills are having biomass, we need to run one extra mill. that is for sure. But as such, when you start even NTPC Dadri जो इतने साल से biomass fire कर रहा है, we don't get that much biomass कि हमें अभी इतना मिल जाए. So मतलब कि बिल्कुल continuous full load पे ही मुझे सब mills में ही feed करना पड़े. As such, the biomass which we are getting the amount जो contractual है, जो सब कुछ है, उस basis पे जो है हमारा 2 mills में maximum काम हो जाता है. Suppose if there are 6 units, if I feed 2 mills each, then that much amount is sufficient. But as such, if we talk about the testing part, that has been tested in as full load also in one specific unit in 4 different 4 individual bunkers, and then one extra mill you need to run for that.
Okay, fine. When we are operating the extra mill, does it call for the heat flux inside the furnace, as because of the non-uniformity of the mixing of these pellets with the coal? And when you are operating the additional mill for a continuous basis, will it call for the irrational part also?
That question can be well answered by the NITRA group, which basically does the research. That will come in the second half session. But as such, if there would have been any changes, we would have known. But as such, sir, हमारा overhauling भी हुआ unit का उसके बाद सब कुछ. There is not much appreciable change. Only thing which we get to see is अगर हम biomass ज़्यादा feed करते हैं तो flue gas outlet temperature थोड़ा ज़्यादा exit होता है. So that's a loss in terms of efficiency जो हमें मिलता है. As such, heat flux में इतना affect नहीं करता हमारे boiler के उसको water walls को और उसके कि हमारे temperatures operating में change आए इसमें. As such.
Hello, sir. Thank you. Sir, you were using a open for storage of pellet.
Pardon?
You were using an open shed for storage of the pellet. So, did you face any issues during monsoon?
Yes, that's an issue which we face during the monsoon. But usually अभी क्या होता है जितना biomass pellet हमारा आता है, just a second, एक बार म्यूट कर लीजिए सर, वो डिस्टर्बेंस आ रहा है. थैंक यू सो मच. अगर जितना biomass pellet आता है, usually हमारा CHP का क्या रहता है priority, that whatever biomass is being received, that should be first and foremost sent to the bunker itself. So as a storage कम से कम हमारा priority है. But monsoons की time, yes, it do require, but हमारी पहली कोशिश यही रहती है कि उसको bunker में ready कर दें. क्योंकि अगर आप अभी देखेंगे that how moisture affects the biomass pellets, that will be shared in the subsequent PPT in the second half. कि कैसे affect हो जाता है biomass का. But usually ऐसा अभी हमने monsoons में इतना ज़्यादा हमें अराइवल होता ही नहीं है पैलेट्स का. मोस्टली जो है दिस कम्स अराउंड एट दिस पीक समर और ये इस टाइम पे आ जाता है. अभी जैसे नवंबर वगैरह में है जब कटिंग का सीजन रहता है. एट दैट टाइम बायोमास पैलेट्स अराइव एंड वी फीड दैट इनटू द bunker.
Hello, Rohit sir.
Rohit sir. Rohit sir.
Rohit sir.
हेलो रोहित सर.
हाँ जी हाँ जी हाँ जी.
हाँ सर, ये फायर सेफ्टी का क्या अरेंजमेंट है पहले स्टोरेज से लेकर हैंडलिंग तक सर अपने यहाँ?
पैलेट स्टोरेज एंड हैंडलिंग में ऐसा कुछ नहीं है बिकॉज देयर इज नॉट मच की दैट वो खुद से फायर कैच करेगा. नॉर्मल बेसिक डस्ट सेपरेशन जो सिस्टम रहता है वैसा है. बट वी डोंट यूज दैट इन वी कैन नॉट यूज दैट इन पैलेट. That is for sure. If you use, the pallet will be of no longer use. Okay. So there is a basically fire tender deputed and all that things which are as an emergency response system, but not, I wouldn't say dust separation system is not used. That is a clear cut no, because if you will use that even in the blended thing, then it will become soggy kind of thing, as you can imagine.
और मील में क्या सर स्पेशल अरेंजमेंट करना पड़ता है अदर देन इनर्टिंग सिस्टम चलाने से?
इसके अलावा मिल में जो इनर्टिंग जो है लॉजिक मॉडिफाई करना पड़ता है, जो मैंने आपको शेयर किया था कि आपका जो कोल्ड एयर डैम्पर है वो आपको मिल इनलेट टेम्परेचर को देख के गवर्न कर, मतलब मिल इनलेट टेम्परेचर को हमें ज्यादा नहीं जाने देना बेसिकली. वो कभी भी हम उसको 190 डिग्री से ज्यादा नहीं जाने. बाकी जो सैंपल आपके पास रिसीव होगा, जो जीसीवी आप बायोमास का फायर कर रहे हैं, जो ब्लेंडेड मिक्सचर का होगा, वो आपका केमिस्ट्री डिपार्टमेंट आपको बताएगा कि इस ब्लेंडेड मिक्सचर का कितना जीसीवी है, कितना वॉलेटाइल मैटर है. उसके हिसाब से आप भी अपना डिसाइड कर सकते हैं. बट दैट्स द स्टैंडर्ड व्हिच वी हैव सेट ओवर हियर. मैं ये नहीं कहूंगा दैट दिस इज द सैक्रोसेंट, क्योंकि हमारी नेत्रा विंग जो रिसर्च विंग है उसने ये चीज टेस्ट करी हुई है. सो उस बेसिस पे वी हैव बीन आस्क्ड कि इस चीज को इससे ज्यादा नहीं रखना. मिल इनलेट टेम्परेचर इज द मोस्ट इंपॉर्टेंट पॉइंट, जैसा मैंने आपको बताया, और उसी में मेरा हॉट एयर गेट का क्लोजिंग भी है.
So these are the different basic, some small modification in the terms of permissive and protection system which has been incorporated in the logic itself.
एक सर आपने बताया था कोल पाइप पे कुछ स्पेशल अरेंजमेंट करने का सेंसर था
कोल
कुछ
पाइप में बस कोल पाइप में टेम्परेचर पॉइंट्स प्रोवाइड कर दिया गया था. इज इट
वो
ओके?
एडिशनल
कोल
यूज
पाइप
किया
में
गया
वो एडिशनली, जैसे आप जानते होंगे अभी कोल पाइप में देयर इज नो प्रोविजन ऑफ टेम्परेचर पॉइंट्स ना, देयर आर नो
राइट सर
टेम्परेचर पॉइंट्स. सो जस्ट क्योंकि हम पहली बार फीड कर रहे थे ना, तो हमें अप्रीहेंशन था कि अरे कोल पाइप का टेम्परेचर कितना हो रहा है, बाहर से आप टेम्परेचर गन से मेजर करेंगे.
राइट सर राइट सर.
What is the location of
Do
this
you
place?
have separate bunkers for feeding the biomass pellet, or you are mixing in the same bunkers, sir?
नेट से डाउनलोड वर्जन नहीं तो देना.
Are you? Am I audible, sir?
लिखिएगा 6.6.3.
Sir, am I audible?
पहले का बगल में.
Yes, yes, you are audible, sir.
Ma'am, I would like to know that is there any requirement of separate bunkers for feeding the biomass
Hello?
pellet? Can
Hello?
mix the,
Hello?
biomass pellet in the same bunker in which we are feeding the coal.
राजेश जी, वो आपके ऊपर है, आप कैसे फीडिंग का मिक्स करते हैं ना. मतलब जैसे यूजुअली इन द अर्लियर टाइम हमारे पास एक रिडंडेंट बंकर पड़ा था जिसको हम रिक्लेम हॉपर के थ्रू करके उसको मिक्स कर दिया था. बट इन अर्लियर जब फर्स्ट टाइम सैंपल रिसीव हुआ था तो उसको तो हमने बुलडोजर से ही मिक्स करके फीड किया था फर्स्ट टाइम. जैसे ट्रैक हॉपर के जहाँ आपका स्टोर रहता है वहाँ पर कोल यार्ड जो रहता है वहीं पर ही मिक्स कर दिया था, यानी मैनुअल मिक्सिंग अगर सिंपल वर्ड्स में बोलो. बट इफ वी आर गोइंग टू एज अ परमानेंट सॉल्यूशन देन वी नीड टू इन्वेंट दैट कि किस तरीके से हम उसको ब्लेंडिंग करें ऑन अ कॉन्टिन्यूस बेसिस. बिकॉज इफ वी आर इन द फ्यूचर, अगर हमें कॉन्टिन्यूस बेसिस पे अगर सपोज कीजिए 2% ब्लेंडिंग करनी है, 3 करनी है, जो भी करनी है, we need to devise the system on our own. Matlab that is there.
Sir, then the question will be
Sir, can we use it in this system also?
moisture level of the coal. Up to what moisture level of coal we can mix the pellet in the bunker, because you are restricting the dry fog and water spray into the coal feeding part. Then definitely the coal moisture will be also a limiting factor in the
छोड़ देना पड़ेगा 15.
As such, no, we haven't observed coal moisture as a limiting factor, to be honest. Share my viewpoint. The only factor which comes into consideration is the moisture content of the pellet, which acts as a rejection factor for the lot which we receive at NTPC Dadri itself. I have provided a video link in the YouTube, in the chat section also. Kindly see that video, you will get to know how do we do sample, and if there is any regarding concern then I will ask some chemistry department team. मैं आपको उसका मेल दे दूंगा, आप मुझे मेल कर दीजिएगा. I'll let them know.
Thank you very much, sir.
Can I reply this?
कोल पाइप टेम्परेचर पॉइंट जो है वो नियर बर्नर साइड में लगाना है कि हमारा मिल साइड से आएगा? तो
This Bhavan sir is trying to answer something. Sir, respected sir, you were trying to answer the previous question.
Sorry, this was related to the previous question, Mr. Grover. Actually, the thing is like whether they wanted to use dedicated bunker or they want to blend it. This is what I explained in my previous presentation. It is up to them. It depends on the amount of the biomass they are co-firing. I would say if they are doing it for something like 10 to 20%, then dedicated biomass separate storage is better. And if they are not, then it can be the same bunker. But in your case, I think you are doing only up to 4.5%. So I think the same bunker still can do. So how much biomass they are going to co-fire, depending upon that, they have to decide. This is what I wanted to answer.
Can use the pulverized biomass in this system also, where we are storing the pulverized coal in bunker, then we use it.
Okay. I can catch your question. Sorry.
So the question is that since as I have understood that they are firing, basically storing the pulverized fuel in the bunker. So the question is whether they can store the pulverized co-blended fuel in the bunker or not.
Yes, sir.
It is
Yes,
not
sir.
advisable. It is not advisable, because normally what happens, I have seen that is once it is pulverized and we need to combust as much early as possible through the through the burner. The benefit is it will not create any agglomeration, but if you're leaving it, then hygroscopic properties of the biomass and the coal, it will stick into that and bonds a kind of a big lump. Then it is difficult for us to transport in the pulverized fuel pipe. So that's the reason it is normally not permitted for storing.
Okay, sir. Thank you, sir, very much, sir. So we need to share the PPT. It is like.
Yes, surely.
Hello, Rohit ji. After using biomass co-firing in your Dadri plant, have you noticed any change in startup time or startup oil consumption of your unit?
No change as such in startup time or startup of my unit. No change as such.
Okay. And the second thing regarding opening of inerting motorized valve, is it auto operation or manual operation from the control room?
It is manual operation. It is all left on the discretion of the unit controller or desk engineer, as you can say.
Is there any problem, sir, in auto operation?
In auto operation, what would be the deciding parameter?
Yes.
Because that is something which I just shown in the last slide. Firstly, steam inert करने से पहले सबसे पहले मेरा कोशिश रहेगा कि मैं feeder maximum करके dump कर दूं उसमें and air काट दूं. The first step is that. And if अगर उससे भी नहीं कुछ हो रहा, then the last is कि मैं steam inerting valve खोल.
In auto operation, suppose during night shift or during odd hour, if any overlook happen by operator, then it will help, na?
How can overlook that happen from the operator? Because something like this, suppose mill fire है, अगर mill fire में भी हमारा रहता ही है ना, because we have SOPs for mill fire also. I hope है ना, if there must be these kind of SOPs which are formed for mill fire also. In that provision also we haven't formed any this kind of auto operation of that sequence. Earlier the BHEL used to provide only manual valve that was located at the remote. So previously जितना मैंने अपना 12 years of experience में ऐसा मिल फायर एक आधा देखा है, but usually अगर हम fuel excess dump कर देते हैं, air काट देते हैं, that stop on its own. अगर timely अगर वो पता लग जाता है, तो उसी sequence में जाना चाहता है, मतलब auto पे नहीं उस पे rely किया हुआ उसने.
Sir, have you installed CO monitor in your coal mill? CO monitor?
No. We haven't installed CO monitor.
Sorry for the interruption here.
Okay, thank you.
Sir, it is already 1:30, so I would request all the participants to please carry forward your questions in our next question answer session that we will be having just before the tea session again. So again, in the end of the session today, we have a 1 hour question answer session. So I request all the participants, I can see there are a lot of participants who are interested to ask so many questions. So I request them to please have patience and we'll carry forward this session again. And now I would like to disperse, we'll disperse for lunch. And now it is 1:30. So from 2 o'clock again our next session will start. So thank you so much Grover sir, thank you Bhavan sir. So I think we will meet each other again during the question answer session. I request all the participants to please have an early lunch and we join for the next session by Subhash Kakkar sir at 2 o'clock. Thank you so much.
One request is from JSW. All the presentations which are showed are good, knowledgeable. Whether we will be sharing that?
Yes, sir. I will collect them and we'll share it. We'll share it, sir.
Okay, then they will be having the contact number so that we can contact them because we will not be able to
I'll
ask.
coordinate with that and inform you, sir. Let me coordinate with you. Okay.
Madam, I am talking from Santaldi Thermal Power Station. I have raised my hand from a long time, but you should maintain the serial. Otherwise, we can't go for question answer. We have a lot of questions to Mr. Rohit ji. So that's why please maintain the serial
but
number.
I was not getting a break in between.
Should maintain a decorum so that we can ask Rohit ji. We have a lot of questions from Santaldi also. Okay.
Definitely, sir. Definitely, I'll take care of this. Let us have this. Continue this.
Okay.
That
Okay.
would be helpful for everyone, ma'am, because I have
Right.
also put my point hand and I've been waiting to get my chance to ask.
Yes, sir, definitely. Actually, I was not getting a break in between. It was so continuous. I am seeing that there is a queue and I am already following. I mean,
Admin वाला ID
not do anything after lunch. Thank you so much. We meet after lunch.
आपका in case अगर कोई भी query हो, just you can also mail it and we can also chat it later on also. In case अगर कुछ रह भी जाता है, so do not
Rohit
issue.
ji, I am talking from Santaldi Thermal Power Station. My name is Nirmala Chakraborty. I am working in O&D department. We have lot of question. You please share your mobile number, your email, so that we can ask
Sure.
later also.
Sure.
In next session, we will ask few questions. Please try to cooperate with us. Thank you.
Sir, don't worry, sir. We have got a very enormous Q&A session around 1 hour. So, and as ma'am already told you, we will go one by one according to queue, and everybody query will be answered.
Okay, thank you.
Thank you so much. Thank you all, and we meet again at 2 o'clock.
आपका फाइल है
Thank you.
प्रोटेक्टेड ही वैसा हो गया फोल्डर का लोगो थोड़ी ना आता है आपका में भी फोल्डर का लोगो आता है हाँ सर हाँ जस्ट शेष हुआ नहीं सर वो बोलने से वो शेष हो रहा था आपको कॉल किए हाँ आप बोल सकते हैं सर हाँ देखिए सिस्टम फट कर बंद होगा अभी करंट जाए हाँ मैम
2 बजे के पहले आ जाना खाना खा के।
हम खाना खा के आ गए
भाव देखा जाओ और एक स्क्रीनशॉट सब नहीं
हाँ
है